VPNs are failing in modern enterprises, and most teams don't realise it yet. They're slow, brittle, and they quietly expand your attack surface by granting broad network-level trust. That's why breaches still happen, even with MFA and firewalls, because the trust model underneath hasn't changed. In the next 5 minutes, I'll show you why the old castle and moat model is dead, and what architecture replaces it. VPNs were designed for a world where users sat in offices, apps lived in data centers, and the network was the security boundary. That hub and spoke world is gone. Here are the 3 architectural failures we'll cover. 1. How VPNs enable lateral movement. 2. The performance and cost impact of hairpinning. And 3. Why identity is the only perimeter that scales now. A VPN creates an encrypted tunnel, and once you're inside, you're trusted. You're effectively given a local presence on the network. You're on the wire, so you don't just access one application, you gain network-level reach. And when identity is compromised, that trust model massively amplifies the blast radius. Because attackers don't target networks first anymore, they target identity to get the initial tunnel. I'm Gia, your GetIT architect, and I see teams trying to solve modern cloud problems with legacy network tools all the time. VPNs operate at the network layer. Once authenticated, you get broad visibility. That's exactly what attackers want. One stolen credential, and they can move laterally, scanning subnets for file shares, databases, and internal services. Modern security needs least privilege. Users should only see the specific app they need, not the infrastructure around it. Even with segmentation, VPN access often flattens controls in practice, or creates bypass paths. If this is already clarifying why VPNs feel broken in your environment, hit like. It helps this channel reach more people designing and running modern systems. VPNs force traffic through central gateways, and modern traffic patterns are internet first and east-west, not hub and spoke. So you end up hairpinning. The user and app might be in the same region, but the VPN gateway is somewhere else. Traffic detours across regions, sometimes across oceans, then back again. That kills performance, creates bottlenecks, and can inflate cloud egress costs, therefore paying more because the traffic path is wrong. Most teams try to fix VPNs with MFA, but MFA is a one-time check at the gate. Once connected, the VPN typically doesn't continuously evaluate device posture, session risk, or changing trust signals. So identity becomes a login step, not the control plane. That mismatch is why modern breaches still succeed. Authenticate once, then inherit broad access. What replaces VPNs is Zero Trust Network Access, ZTNA. Instead of connecting to a network, you get brokered, policy-driven access to a specific application session. Often it's delivered through an identity-aware proxy at layer 7, so users never touch the internal network at all. And the app can sit in dark space, not exposed with a public IP, not easily discoverable by scanners. This is why identity becomes the new perimeter. And I'll break down that architecture step by step in an upcoming video. When I say layer 7, I mean application level access, connecting to a specific app, not a network. I'll build on this concept across upcoming Zero Trust and Identity videos. This isn't a tool swap, it's an architectural shift, away from trusting networks, toward explicit policy-driven access based on identity and risk. VPNs simply don't fit that model anymore. VPNs are failing because they trust networks, and modern systems don't work that way. In the next video, I'll show how identity replaces the perimeter and the practical roadmap teams use to move away from legacy VPN access. If you want clear, real-world architecture breakdowns like this, subscribe. There's new videos every week.